In this video, we'll explore the fundamentals of Flutter and Firebase. We'll take a deep dive into essential Firebase features including user sign-up and sign-in, as well as auth state persistence. Additionally, we'll cover how to work with Cloud Firestore and Firebase storage. Throughout the tutorial, we'll discuss the significance of these services and how they simplify app development with Flutter. The prerequisite for this tutorial is the basics of Dart and Flutter. You can find the starter code for this project linked in the description, so feel free to clone it to understand the project better and follow along. Also, subscribe because the button lights up when I say it, and now let's get into the tutorial. So our first step is to connect our Flutter application to Firebase. And to do that, we're going to go to console.firebase.google.com, then click on create a project, then enter the project name. For me, I'm just going to pass in Firebase tutorial like this and click on continue. After that, it asks me if I want to add Google Analytics to this project. Google Analytics provides insights into user behavior within the application. It helps us track and measure app engagement, retention, user interactions, and it provides detailed reports on user demographics like where they're from. And for this project, we don't need anything, so I'm just going to disable it, then click on create a project. After the project is ready, we can click on continue. And then it tells us that we can get started by adding Firebase to the application. Here you can see Apple, Android, web icons, but there's also a Flutter icon that we want to select. So you can go ahead and select it over here. Then it tells us the steps to add Firebase to our Flutter app. So it says first to install the Firebase CLI, then we can run Firebase login to login, obviously. So we're just going to go to the Firebase CLI instruction, and here you can see that if you're on Windows, you can follow this. I'm on macOS, so I'll just click over here and here I am. There are multiple ways to install it. We're going to use the NPM way, which is the Node Package Manager. So for that, you would need Node installed in your system. If you don't have that, you can simply go to nodejs.org, click on download. And if you're using Windows, you can select Windows. If you're on macOS, just follow these instructions. If you want a pre-built installer, you can use this one as well. For me, I'm going to install Node.js version 20.17. I'm on macOS and I'm running ARM64 version. So I'll click on download Node.js. And after it is downloaded, you can double click on it. Then it will pop up the installer. Click on continue, agree to the license. Then install it on the computer, then I need to pass in my password, and then it will start the installation. Once it's done, we can go to the terminal and just type in node-v, and it says version 20.17.0, so that means Node is successfully installed. Now I can close this Node.js installation website, go back to Firebase CLI, click on npm. Now I've installed Node.js. I did not use NVM for this, but if you wanted, you could use that, but Node.js is still fine. Now we need to install Firebase tools. So let me copy this code, go to the terminal, paste it over here. What this does is install this Firebase tools package globally in our system. So we can just click on enter, and here you can see I get an error because permission was denied. That's because I've run npm install, but it needs sudo access. So I'll go back and type in sudo npm install -g Firebase tools, click on enter my password. And as you can see, it added 642 packages. It's installed now. The next step is to continue to login and test the CLI. So now we want to do Firebase login, right? That was the next step written as well. So we can just do Firebase login. Then it asks allow Firebase to collect CLI and emulator suite usage. I'll just type in yes. Then it takes us to the page to authenticate. So I'm going to authenticate and come back. So after the CLI login was successful, we've completed all the steps that were present over here. We've also created our own project using Flutter Create. So we can go ahead and click next. So now the next step is to install and run the Flutterfire CLI. To do that, we need to copy this command. But first, what is Flutterfire CLI? Till now, we have added Firebase locally to our system. Now what we want to do is instantiate the Firebase in our Flutter application. And to do that, Flutterfire CLI can help us. And this definitely makes a lot of the part easier when it comes to installing Firebase to Flutter app. So let me just go ahead and copy this line and paste it in the terminal. As you can see, it installs Flutterfire CLI, but it also tells me to add this line to my shell's config file. If you're using .zshrc or .bashrc, you can open whatever and paste this line in. So I'll just copy this line, then go to vim.zshrc and then paste this line in. After that, I can press escape:_WQ. And if I want to see that the line still exists in .zshrc, I can simply do cat.zshrc. And as you can see, this line shows up. And that means that the file is now updated with this line. Perfect. If you don't want to get into this mess, you can go ahead, copy this, paste it over here, and it should still work fine for you. But the problem with this approach would be that every time you close and reopen the terminal, you would have to run dart pub global activate flutterfire CLI and then again copy and paste this line. So instead of doing this every single time, you can just add it to your path and you're fine. The next step is to copy this line, go to the root of the Flutter project directory and run this command. So let me copy this. So now I'm at the root of my Flutter project. I can simply paste the line, click on enter, and it fetches available Firebase projects. It will select the project that I mentioned over here. Then I can select and deselect whatever platforms I want to support. I don't want to support Windows, so I can simply press space and it deselects it. Then I click on enter, and then it asks me for the Android application ID. If I want to check the application ID, I can go to build.gradle android/app. Then I have com.example.frontend, which is my ID. So I'm going to paste that in com.example.frontend, click on enter, and it registers the Firebase projects, Android app, iOS app, web, macOS, everything. And after everything is done, it will tell you all the IDs for all the platforms. And it also says that a new file was generated, which we are going to take a look at in just a minute. But first, let's see if there's any other steps to follow. And if we click on next, it says to initialize Firebase and add plugins to the Flutter project. And here we have the Firebase core package that we want to add. Basically, we have created a new project in the Firebase console. And now we want to connect the Flutter and the Firebase applications together. So we ran the Flutterfire CLI. So what it did is if we go to the lib folder, here we have Firebase options.dart file. Here what it tries to do is mention all the code related to connection of Firebase and Flutter so that we can simply go to the main.dart file and run a specific line of code, which is await firebase.initialize app, and this will connect Flutter to Firebase. And obviously to do that, we need the Firebase core package. And to install that, we can go to pub.dev, pass in firebase_core. As you can see, published 3 days ago by firebase.google.com. We can simply copy this, go to the pubspec.yaml file, scroll down and add it as a dependency. Once it's done, as you can see, the error goes away in Firebase options.dart file because we have the package now. And now in the main.dart file, we need to convert this to async, then do await firebase.initialize app and make sure you've imported Firebase core. This Firebase comes from Firebase core. Then we pass in this and it asks us if we want to pass in demo project ID, name or options. I want to pass in the options and my options are going to be default Firebase options.current platform. And this is coming from the Firebase options.dart file. If we go over here, as you can see, default Firebase options is a class and here it tells us to get the current platform, which is what we are doing. And when this is run, it basically gets the current platform we are on. Are we running the Android app? Are we running the iOS app? And if it's Windows, it throws an unsupported error. Firebase options could not be configured because we didn't support this. We didn't support Linux because by default, Firebase doesn't have support for Linux yet. And if we scroll further, you will also see that these are the Firebase options for web, Android, iOS. So basically what it's doing is whenever it gets iOS, macOS, it goes and retrieves these Firebase options that have been stored over here. And then it returns it to this options because it also is of the type of Firebase options, right? So after this is done, we are good. But there's one other thing we want to do, and that is widgets flutter binding.ensure initialized. Once we do that, everything will run smoothly. And the reason we need to add this line is because run app by default has this line, widgets binding.ensure initialized. But before running the app, we have added firebase.initialize app. That means widgets flutter binding was not initialized yet. So here we have put this line that, hey, make sure it is initialized. And after that is done, I'm going to start my iOS simulator and see if all the setup was done correctly. I'm also going to run the Android application just to make sure it works well on Android, and then we can get started with further code. Now, as you can see, the iOS simulator stopped by launching an error, and it says Firebase core requires a higher minimum iOS deployment version. So what we want to do is go to pod file and here uncomment this line and pass in 13 as the version. Then we can save it, close this, then we can run without debugging the iPhone 15 Pro Max as well. For the Android one, as you can see, everything works perfectly. So we are ready to get started with the authentication part. And the iOS app has also launched successfully. So now we are ready to get started with authentication. So let's go back to our Firebase console, continue to the console, Flutter app is now added. Then what we want to do is click on build. And here you can see we have app check, app hosting, authentication, all those sorts of things. We want to click on authentication, then click on get started. And here first we need to pass in the authentication providers that we want to allow. Do we want to allow email password authentication, Google authentication, phone authentication, anonymous sign-in? Basically, the user can sign in without doing anything. Microsoft, Facebook, Apple, all sorts of things. I just want to allow email or password for now. I'll click on enable here. I don't want to allow email link passwordless sign in. So I'll just click on save by doing this. Now, if you want to know more about how we can add other types of authentication methods, you can watch the video I've created on it. Now you also have the option to edit the templates for email address verification, password reset, email address change, all those sorts of things. So if you want to go ahead, try it out, feel free to do so. But we're going to go to the users tab and try to add our particular user over here. And to do that, again, we'll need some sort of package. Firebase core by default doesn't allow this. And that's why we have the Firebase _auth package. So we can go ahead, copy this, then press Command Shift P, Dart add dependency, then click on Firebase auth, and then hit enter. After that's done, we can go to the sign up page and start writing the code so that we add or create a new user to the Firebase authentication console. So for this, I'm going to specifically create a function here, void create user with email and password. I'll try to be as descriptive as possible. Then I'll create a function, and now I'll use Firebase auth. So make sure you use Firebase auth, not Firebase app. This comes from the Firebase auth package dot instance, and this Firebase auth dot instance is a singleton. Basically, it means that whenever you try to use this Firebase auth dot instance, it will give you the same instance of Firebase auth every time. It doesn't create new instances that we had in objects. So after we have this, we can click on full stop and it gives a ton of methods we can use. What we want to do is .create user with email and password. Then I need to pass in the email and the password. So let me minimize the Explorer. So we have more space, and the email is going to be email controller.text.trim. All right. And the password is going to be password controller.text.trim. And this function is going to return future of user credential. So I'm going to await this. Then I'll have final user credential, which is equal to this. And also pass this function as asynchronous because you're using await here. And this is future void as a result. Then I can go ahead and print user credential over here. Copy this create user with email and password function and add it as an on press to the sign up button. So I'll just do async, await, and then pass in this create user with email and password. Then I'll click save, restart my application for iOS first. So let me go ahead and try this email. Revan@gmail.com. Password will be test, let's say. Then we click on sign up. And if I open the terminal, it gives us an error. it says unhandled exception, unable to establish connection on channel, and that's because we didn't restart the application after adding a new plugin. So let me do that really quickly for both the platforms. After I've done that, I'll try it again and let you know. And the Android app failed to launch this time because it says that the minimum SDK version required is 23. So we need to go to build.gradle android/app, scroll down where we will find minimum SDK, and we want to change it to 23. Then we'll click on save and then launch the Android application again. The iOS app is now launched, so let's try it. I'm going to pass in rivan@gmail.com, test123, or actually just let me pass test, click on sign up, and here it says unhandled exception, Firebase auth weak password should be at least 6 characters. That means Firebase auth package is working fine. The connection was established, but we still somehow need to handle this exception. And to do that, what we can do is simply wrap this entire thing with a try and catch block. So if there's any exception, it will show up over here. And then we can go ahead and print this exception. Or if you want, you can add a snack bar over here so that the user gets more detailed information. Or if you want to go above and beyond, there's another thing you can do. You can add on Firebase auth exception catch. So you're only catching a particular exception, which is Firebase auth exception. Now this E is of the type of Firebase auth exception. That means you can have E.message given out to the user every time there's a Firebase auth exception. So let me open up the terminal, restart the iPhone simulator. Let's pass in rivan@gmail.com, test, I'll click on sign up, and it says password should be at least 6 characters. Perfect. No unhandled exception here. I'll also increase the character length now. So we have test 1, 2, 3, click on sign up. The user credential that we printed shows up over here, and it has additional user information, the email of the user, phone number if there's any, photo URL, provider ID, refresh token, tenant ID, all those sorts of things. And if I go to my Firebase console, click on reload over here, we have a new user. Now let's see what happens if I try to sign up again. And when I do that, it says the email address is already in use by another account. So we cannot create a new user now. We need to log in for that. So with just this much, we are able to create a new user. That means we are able to sign up the user. Also, if you notice over here, we have the user UID. This is a unique user ID. That means if you want to uniquely identify a user, you can do this with the UID. And if you want to get access to that, you can simply do user credential.user.uid. Or if you want to get all the details of the user, you can simply do this. All right. But this will give us the particular UID, which is over here. Now, if you want to know more things that can be done with the Firebase auth package, again, I recommend you to watch the video that I've created already. Now I'm going to jump to the login part so that we can see how we can log in. And then we get to the real deal, which is the Firebase Firestore, so that we can store all of our information. So now I'm going to go to the login page, and here, similar to the sign up page, we're going to have future void login user with email password. Then this is going to be asynchronous, and then we're going to have a try and catch block, and we're going to catch the Firebase auth exception. Make sure you import the Firebase auth package, catch E, and then we're going to have print E.message. After that, I'm going to do await Firebase auth.instance. And again, remember, this is the same instance that was used over here. So we have Firebase auth.instance sign in user with email and password. So we have that. Now we can pass an email and password, which is email controller.text.trim. And then we have password controller.text.trim. After doing that, we can put a semicolon over here, which I forgot, and save the file. Again, this is going to give us a user credential, which I can store over here. So we have user credential equal to this. Then I'm going to go ahead and print the user credential. Also, one thing I want you to notice is that over here in additional user information, it says is new user true. That means the new user was newly created. And actually, before trying it out, I want to connect this function to the on pressed of this button. So whenever we do sign in, I want to do await login user with email and password. In the iOS application, if we go ahead and click on sign in, then pass in my email, revan@gmail.com, pass in the password test123, click on sign in. Here it gives me the user credential, and if I pass in 3, 2, 1 is gone, I click on sign in, I get supplied auth credential is malformed or has expired. It doesn't tell you that the password was wrong or the email was wrong, nothing of that sort. And that's because if you go to the settings, user actions, we have email enumeration protection on, which is recommended to be on. If I toggle this off, click on save, now click on sign in, it says the password is invalid or the user does not have a password. Much more descriptive. But to protect ourselves from this attack, we'll just click on save. So the sign up and the login is done for the iOS application. Let's test it on Android as well. And if it works, the next thing we want to do is whenever we restart the application, we don't want to land up on the sign up or the sign in page. Right now we do that because if we go to the main.dart file, we have sign up page written over here. We want to do this conditionally based on whether the user is logged in or isn't logged in. If they are, they'll go to the home page. If they're not, return to the sign up page. And that is easy to do as well with Firebase. So first, let's just test it on Android and then we'll go to the auth persistence part. So let's create a new user here. It is ranavat@gmail.com. Password is test123. And if we go to authentication, ranavat@gmail.com is now added. If I go and sign in, we have ranavat@gmail.com, test123, click on sign in, and here we have the user credentials showing up. And if I try to do it with an incorrect password, you'll notice that we have the supplied auth credential is incorrect, malformed, or has expired. So the same errors, both the places. Now let's move on to auth persistence. The problem that we want to tackle with auth state persistence is that how do we display a home page when the user is logged in and a sign up page when the user isn't? To do that, we first need to know if the user is even signed in. And to do that, we can simply do one thing, right? We can simply do firebase auth.instance.current user. And if you notice, this current user is of the type user that can be nullable. So if the current user is null, that means the user is not there. The current user is not there. That means the user is not signed in. So we can display a sign up page over there. And if the user is signed in, the user is going to be there. It's not going to be null. Then we can display a home page. So if I just do is not equal to null, then we are going to have a home page. Otherwise, we are going to have a sign up page. And this way, if I restart my application, come over here, we are logged in. However, there's a better way to do this in Firebase. Instead of doing all this, we can simply wrap our sign up page with a widget of Stream Builder. Then this Stream Builder is going to accept a stream, which is going to be firebase auth.instance.auth state changes. This auth state changes is a stream of user. Earlier, we only had a user that was nullable. Now we have a stream of user that can be null. The benefit of this is that it's a stream. It's a continuous real-time value. And this real-time value updates whenever the user decides to sign in or sign out. Earlier, when we had firebase auth.instance.current user, it wasn't real-time. It was synchronous. This is asynchronous. So whenever the user changes, this thing is going to rerun. And because of that, we have real-time update of moving from the home page to the sign up page as soon as the user logs out. We don't have to do anything manually. In current user, we would have to do it manually because until we restarted the app, the user wasn't logged out. So this is a much better way of going about it. Now here we can simply do if snapshot dot connection state is equal to connection state dot waiting, as we do with every stream that we get. If it's still loading, then we want to return a centered circular progress indicator, right? Now we can save this much, and with this we have handled the loading state. Now how do we know if the user is logged in or not? To do that, we can use the snapshot again. As you can see, the snapshot is of the type of async snapshot user. So we need to get this user value out of this async snapshot. And to do that, we can simply do snapshot.data. And with this, we have the user. And now I can check if snapshot.data is not equal to null. That means we are logged in. So we have return constant my home page. And with this, I can save the file, restart the application. I come over here and I'm logged in. There's no visible difference, but whenever I log out now, I don't have to manually say navigator.offcontext.push and take me to the sign up page. No. All I have to do is just do firebase auth.instance.logout, which is how I can sign out. And then the stream will trigger, because of which I'll get back to the sign up page, because now snapshot.data will be null. So this is the basic way of going about doing auth state persistence. Now there's two other methods instead of auth state changes that you can use over here. The first one is ID token changes. Earlier in auth state changes, this stream got a new value whenever the sign-in state changed, right? Whenever there was a sign-in or a sign-out. But with ID token changes, the stream is going to have a new value when the ID token is refreshed, or when the user signs in, or when the user signs out. ID token is a JWT, JSON Web Token, that Firebase uses to verify the user's identity with secure services. Now, whenever this ID token refreshes, this will get rebuilt, or whenever the user's ID token changes due to updates in account information, security settings, even then the stream is going to get a new value. And obviously this also gets rebuilt whenever the user signs in or signs out. So this is kind of like a superset of auth state changes. Other than ID token changes, we also have user changes. Now this gets rebuilt whenever the user object that this stream returns changes. And this user object will change whenever there's change in user properties such as email verification, password updates, profile updates, name change. This can be considered as a superset to ID token changes because it also updates whenever the ID token is refreshed or changed and whenever the user signs in or signs out. So it rebuilds whenever there are three triggers: changes in user properties, the user signing in or signing out, and ID token getting refreshed or changed. And in our case, we only care whether the user is signed in or signed out. So I'm just going to use auth state changes so that I don't have any side effects. And with this, I'm done. If I restart, I'm on the home page. Everything works fine. Now, the next thing I want to do is whenever the user comes to this page, they decide to see other people's tasks and their own tasks, right? So for that, they need to upload their own task. And to upload their own task, they will click over here, add in a title, description, color, select a date, and click on submit. So whenever this new task is added, I want to take this and store it in my database. And after that data is stored in the database, I can fetch all of those tasks present in the database and display it over here. Now you might ask, why are we storing the task in a database? And the reason for that is quite simple. Let me demonstrate to you with a diagram. Let's say this is our task, right? You have the name, description, date, color. And this is our big database. We're storing this task in the database, and from this database, we are going to fetch it and push it on our application, right? This is where our task is going to be. Now you might ask, why do I need a database in the first place? I can just take this task and display it on my phone using some state management tool or something. And you're right, you will be able to do that and you will be able to see it temporarily, but you won't be able to see it forever. And the reason for that is as soon as you restart your application, all the data stored in the state management tool is going to disappear. Data stored in state management tools is only temporary. It's not stored permanently. That's why we're using some sort of database to store our data permanently, and every single time the user loads the app, we're going to fetch it from this database and display it. Also, this gets necessary when there are other people using the application. In Task Management app, we're only trying to display our tasks. But what if you're building a social media application like Instagram? You want to see everybody's task, right? So let's say this was your device and you added a new task, but there's some other person who is having a title, description, date, and color, and they want to upload as well. So they'll upload it to this database. Now the retrieval job is simple, right? It's just going to get all the records that are present in the database. So your task that was present will be fetched, and even the task that was uploaded by the other user will be fetched. So you'll have another task displayed over here. So this way you've created a social media application which fetches posts or tasks of different people. So you can think of this database as a directory containing permanent records. Everyone is going to upload over here. This is the ultimate source of truth, and everyone is going to retrieve from this. So everyone has the same data that's present over here, and it doesn't cause any problems to them. This is how a social media application would work, but in our task management app, if we're storing the data over here, we only want to fetch a particular user's task, not the other user's task. That's invasion of privacy, and we don't want to do that. And we'll figure out how to work through that. But first, let's just upload all of the data to Firebase, and then we can try to retrieve all the data, and then we can try to filter according to a particular user. So let's get into it. Now, how do we store data in Firebase? We can't do that using Firebase Auth because that's only for authentication related tasks. It has nothing to do with data storage that we want. For that, we can go to the Firebase console. If you click on build over here, you'll see that we have Firestore database and real-time database. We'll be using Firestore database as our database of option, not real-time database. And that's because Firestore is basically better than real-time database in almost every scenario. If you want to take a detailed look at the comparison, you can look it over here. Choose a database, Cloud Firestore or real-time database. You'll see that Cloud Firestore is the recommended enterprise-grade JSON compatible document database. And real-time database is the classic Firebase JSON database. Basically, real-time database came in before Firestore. It's suitable for applications with simple data models requiring simple lookups and low latency synchronization with limited scalability. And if you want to take a more detailed look, you can look at these things and decide for yourself. But for us, we are going to use Firestore because that's the recommended way. So we can click on Firestore database over here, then click on create database. The database ID is default. We can select a location, and after we've set the location, we won't be able to change the location the database is set in. So make sure you select a wise one. After you've selected the location, you can click on next, and then you have two options: start in production mode, start in test mode. We're going to start in test mode. And the difference between test mode and production mode is the way rules are written. Everything else remains the same. In production mode, the data is private by default. That means nobody will be able to see it. And in test mode, the data is visible to everybody. So we are going to start in test mode, click on create over here, and there we have our database. Now, anytime in Firestore you want to update the rules, you can go over here and edit it for yourself. As it's written over here, you can guard your data with rules that define who has access to it and how it is structured. So it's a very important part of Firebase applications. Then you also have indexes, as it mentions over here, will help you to create compound queries. Compound queries is basically like complex set of queries that will allow you to search better in your application. It will allow you to filter better. We'll understand more about filtering later on, but for now, just understand indexes exist that help you to match multiple fields in a collection. And in the usage tab, you get to see all the metrics of your Firestore database. Now, one thing to note about Firestore is that you have 50,000 reads every day. That means you can read from the database. You can fetch all the data from the database only 50,000 times. It's fine for the application that we are building, but when you get more users, you'll have more reads. And then you will have to enable billing, which will basically take money from your credit card or your debit card, whatever. If you want to know more about it, you can click over here and read the Firestore usage thing. But for now, let's get back to the data. Now, how are we going to store the data in Firestore? Now, the way Firestore works is you need to define a collection over here, and there can be multiple collections. What is a collection? A collection is a container of documents. It is a way of organizing related documents together, right? It's kind of like your drawer, and you can have multiple drawers over here. So here my collection is going to be tasks, right? I want a drawer that contains all the tasks. So I can click on next, and then it tells me to add a first document. Now I told you collection is a container of documents, and here it's asking us to add the first document to this. So for this, we need a document ID. So I'm just going to click on auto ID for now. Then it tells me what field does this document have? Like what are the fields that we want to store over here? In our task, we saw that we needed name, description, date, and color. So I'm going to go ahead and pass in the title, which is the name, And this is going to be a string. The value can be, let's say, my task. Then we need a description. And this description is also going to be a string. And it's going to be my description. Then we need a date, right? The date can be a string if you convert it to one, but if you click on this type, you can pass in multiple more things. For me, it's going to be timestamp because date is going to be timestamp, right? And now I can select a date and a time. So I'm just going to select 5th October and 12:30, whatever. Then I can add another field, which is the last one, color. And this color can be a string. It can be a number because we are going to take whatever color we had in RGBA format and convert it to hex code and then store it in the database. So it's going to be a number that is going to have 6 characters. So I can select number over here and the value can be FFF or 000, whatever I want. FFF is white, 000 is black. So I can just have 000, 000 or just 3 zeros. Both of them are fine. Then we can click on save. And as you can see, we have a collection task. Then we have a document. And then we have the exact data that we have stored in the database. Now, if we want to this task collection, we can add another document, which will be another task. And again, document is just a way to store key value pairs. And this document ID, as you saw over here, was auto-generated. It can be generated by Firestore, or you can also provide your own document ID if you want it. Another thing to note over here is that documents can also store another form of collection. So documents can have sub-collections. If you want it, you can create another collection over here and then continue after that. In our case, we don't need anything, but just in case you need it, you can do it. Alright, so this is the basic way of structuring Firestore databases. Let's see how we can implement this in code. So first of all, we need a way to interact with Firebase Firestore. And to do that, just like we did with Firebase Auth, we'll have to install a new package, which is Firebase Firestore. And actually, sorry, it's Cloud Firestore, not Firebase Firestore. So we can copy this, add it to our pubspec.yaml file, and then we can start coding. Now what I'm going to do is close all the save files and go to the add new task page, because whenever the user clicks on submit button on this page, I want to upload the data to Firestore. So here I'm going to have a future void of upload task to database, and then it's going to be asynchronous. Then we are again going to have a try and catch block. Whenever we are interacting with any Firebase package, I would recommend you to have a try and catch block. In this, we are going to go ahead and print E, but if you want, you can have a snack bar over here so that you display a better error message to the user. Now, how do I store the data in Firestore database? For that, we'll again have Firebase Firestore, just like we had Firebase FireAuth, Firebase. We're going to have Firebase Firestore dot instance. Again, this is a singleton. Only one instance is created every single time. If you want to take a look, press Command, go inside over here, and you'll notice that it returns an instance using the default Firebase app, and it returns the same instance all the time. Then we can have dot collection, and as you can see, I can mention my collection over here. Where do I want to store it? I want to store it in the tasks collection. Then if I want, I can specify the document ID over here. What is the document ID that I want to do? If I don't mention anything and directly call dot add and add the data that I want to, it's going to be auto ID. But if I mention dot doc, let me remove this, and I specify some sort of ID, let's say 12345. It's not recommended to have 12345 all the time, because whenever a new task is uploaded, it needs to have a different ID. If it has the same ID, what it's going to do is go to the task, go to this particular ID and update its data. So it will override the already existing data, and that's why you need different uniquely generated IDs. So in our case, first, let's just get started by doing dot add and add the data. It's going to be auto-generated ID. I'll show how we can create our own ID and store it in the database in just a bit, but first let's just do this. Now I need to pass in the title, and the title is going to be titlecontroller.text.trim. Then we have description, which is going to be descriptioncontroller.text.trim. Then we're going to have a date, which is going to be Well, the timestamp. Now, how do I get the timestamp? For this, we can have datetime.now, which will give me the current date and time. But there's a better way to do this, and that is using Firebase server timestamp. For that, we'll have to use field value because we want to insert a value in a particular field, right? So it's going to be field value dot server timestamp. And this field value comes from the Cloud Firestore package. And this timestamp is going to give us the current timestamp. If you notice, field value also has other things like array remove, array union, meaning if there's an array that needs to be stored in a particular document, you can add to that array or you can remove from that array. It can be useful when you want to store likes of a particular post, right? So you'll have a document that is going to have a particular post details and it contains likes field, which is an array, and that array contains the user ID, and those user IDs are basically the people who have liked the post. And now whenever a new user likes the post, you can simply do array union, or if they remove their like from the post, you can do array remove. So it removes from that array the user's ID. Then we also have delete. It will delete a particular field. Increment, basically increment the value that's present by 1. So let's say you have a like counter. You can increment that like counter by 1, but usually no one does like counter just like that, because if the same user keeps on clicking the like button, you'll keep on incrementing it. There's no way to know that it's the same user. That's why we store the ID of the user and we use a list. And then finally, we have the server timestamp. Finally, we are going to have the color, and the color is going to be converted to a hex. And to convert a color from hex, I have created a function in utils.dart. So we can simply do RGB to hex. Make sure you import utils.dart and pass in the selected color, which is the selected color over here. After we do that, we'll be storing the data to the database. And if you see, we have a future document reference map string dynamic. So what I'm going to do is go ahead and await this. Final data is equal to this, and then go ahead and print data, which is the document reference. If I do data dot, you'll notice that I have collection, delete, get, set. So what is this document reference? It is a reference to the document that was just added. And if we want, we can go to its collection or delete it or get data from it if we want it. In our case, I'm just going to go ahead and print this data dot ID so that I see what auto-generated ID was given to us, right? Now I can save this, I open my terminal, restart the application, add new task, and I just realized I've not bound this function to the submit button. So let me just add this over here, async, await, and upload task to DB. So in the title, I'm going to say my task 2, description is going to be description 2. Then for the date, I'm going to select 8th October, and let me select a shade of purple that's a bit lighter. Then click on submit. And as we can notice over here, there's a format exception of E1BEE7, and that's because in my utils.dart, I have done in.parse and tried to convert this string to an integer, which is not right. So we can remove this in call over here and just return a string instead. So in our database, instead of using an integer over here, we're going to store a string. So now let me remove the data from the terminal, click on submit again, and it says unable to establish connection, and that's because we've not restarted our application. So make sure you restart the application after installing the package, and I'll see you after the app is launched. Alright, so the app is now loaded. Let me quickly add some new tasks. So I have my task 1, then we have description of task 2, then we have an October 8 date, and let me select the color with the shade. Now click on submit. And as we can see, we get the ID written over here, and this ID will match with the ID that's stored in the database. Also, you saw that green highlight for a bit that indicated that the new data was added, and this is it. And actually, now that I realize, the date is being taken from the user. We don't have to upload our own date. The selected date is going to be the date over here. So I can simply change this to posted at, and then this can be the real date. So we have selected date passed over here. And now if I try to submit it again, you'll notice that we have another document. It doesn't care that the title and the description are the same thing. No, the IDs are different. so the data is different. That's how it figures it out. So the ID plays a very crucial part in this. It will determine if a new data is added or the data is being updated. So now if I go over here, the color is present, date, posted at, and description. Also, if you want to delete some data from the console, you can simply do it by clicking on these three dots, delete collection, to delete the entire collection. If you want to delete a particular document, you can click on this button that is present over here and delete it. And with this, we're done. I'm now going to add my task 1 again. And as you can notice, the data doesn't show up over here. Because whenever you create a new collection, because right now no collection exists, you have to refresh the page. And once you refresh the page, the new data will be displayed. Now, whenever a new document is added in a collection, it will display. And as I said before, you can have multiple collections over here. Like you have tasks, you can also have users. And that creates a very good question you can ask, which is, why did we use Firebase authentication? Why couldn't we just store users data over here? So we have the email, name, password, everything stored in Firestore database. And then we can use that data to perform the authentication by ourselves. And you can definitely do that, but it's not recommended to do it this way. It's recommended to use Firebase authentication because first, it gets a lot easier. All of the logic is abstracted away in one method of sign up or sign in. You don't have to create your own logic. And the second one is security. Firebase Auth is specifically designed for secure user authentication. There are multiple behind the scenes operations that happen when you do authentication. Like there's password hashing, there's account creation, there's token management that I talk about, JWT. Also, authentication tab here has a lot of features that you don't need to implement, like email verification, password reset, and we also saw that you can integrate with various other authentication providers. There are also various security compliance requirements that Firebase authentication solves for you. So whenever you handle sensitive user data, there might be a security compliance requirement that you need to perform, and Firebase does that for you. So you don't have to worry about anything and you can securely deploy your application in most places in the world. So I hope that's clear. Now we have added a task to the database. Now let's go ahead and try to retrieve that data and display it over here. So for that, I can go to the home page now. I'll close all the save files, go to the home page, and you'll notice that this is the main part that we want to edit. And that's because we have an expanded widget, which means it takes away all the space that's available. And then we have a list view builder displaying the card over here. So we want to edit this. We want to get the data from the Firebase Firestore database. Make sure that the item count is no longer 3. It is updated to whatever Firebase has to give us. And then we have the row expanded and the task card displays the color that's stored in the database. So let's get started. Now, how do we do that? How do we get data from Firebase? And we actually saw an instance of this in the add new task page. We had Firebase Firestore. So let me just type it out. Firebase Firestore.instance.collection. And we want to go to the tasks collection, right? Because I want to fetch data that's present over here. And then I want to get all the data that is present within the tasks collection. If I wanted a specific task, let's say this particular task, I can copy this ID, pass it in over here, and then call the get method on it. And that would get me the data, a particular document data. So if you notice, this get is of the type document snapshot. You're getting a snapshot, a picture of one document. But what I want to do is get all the tasks in the collection. So I'll just call get on the collection, and that would give me query snapshot. And this query snapshot is going to contain multiple documents that we can access. And also, if you notice, this get is of the type of future. So we'll require a future builder so that we get a snapshot, and then we can build on based of that. So I'm going to wrap this expanded widget with a widget of future builder. This is going to require a future, and this is going to be our future. Collection tasks get. Now we're going to have builder, and this builder is going to give us context and snapshot, and we're going to return an expanded widget. Now the snapshot, as you might guess, is async snapshot. Just like we had in Stream Builder, we'll have to handle the waiting connection state. That means the data is still being loaded from Firebase. So let me convert this to a block body, and to get this you can simply do Ctrl+Shift+R, convert to block body, and now I can check if snapshot.connectionState is equal to connectionState.waiting. That means the data is being loaded. I can do return constant center child circular progress indicator, and there we go. Now we have the data, or at least we're assuming we have the data. Let me just remove this assumption. I can simply say if snapshot.data is not equal to null, or you can basically do snapshot.hasData. If you do this much, you'll notice that behind the scenes hasData is doing data is not equal to null, what we did earlier. So it doesn't really matter. We can do either of them. If snapshot has data, that means this tasks collection has some documents present over here, then we want to return this list view builder. But if it does not have data, so we'll put a bang operator over here, then we're going to return a text that says no data here. Also put a const over here, enter, and there we go. So if snapshot has no data, it returns this text. And if the snapshot has data, it's going to return this list view builder. Now we want to update this, right? The item count is no longer 3. It's going to be based on the data. So we are going to have snapshot.data.docs.length. And this data, it still shows up that it can be null. So I'm just going to put a bang operator over here as well. Then we can click on save. I'll restart the entire app, and you'll notice we only see one card because our database only has one document. Now, if I want to update the header text, the description text, I can simply do that. I can do snapshot, and let me remove this const from expanded. Then we have snapshot.data.docs. This snapshot.data.docs is basically a list of query document snapshot, meaning the documents IDs that are present over here. It's a list of these things. Now what I want to do is get access to one particular document ID and get its data. So to get the particular thing, I can just do @index because this is a list, right? And we are in a list view builder. So I can get its index and get this document over here. Now I want to get this document's data. So I can simply call .data on it. This data is of the type of map of string, dynamic, because it's giving us this key value pairs, right? So I want to get the title. So I can simply do title like this, save it, and we'll notice we have my task 1 written over here. I can do the same thing by copying this entire thing and putting it as the description. So we have description over here, save it, and we have task 2 written. Now if I want to return the date, I can simply do this followed by date over here. And as you can see, type timestamp is not a subtype of type string because this date is of the type of timestamp over here. We want to convert it to a string, so we can do that. And if you want to format this further, you can use the Intel package or just manually write the logic by yourself to display it in a nice format. And that's totally possible. But for me, I'm just going to leave it over here. We don't care about formatting as of now. For the color, we can convert the hex that we have stored into an RGB. And to do that, we have a function in our utils.dart package, which is hex to color. And then I can pass in the hex, which is this particular line over here. So I can pass in the color and we see the pink color showing up. Perfect. So this way we have fetched all of the data from Firebase for a particular collection. Now I'd like to go over this again because it can be a bit tricky to understand. So what I've done over here is I've gone to the collection tasks. So I've gone to this task and fetched all of the documents that are present over here. Then I got a snapshot of that data and then I checked if the connection is still loading. If it is, we display the loading indicator. Then if there's no data, we say no data here. And then we display a list view builder containing the item count. Now for the item count, we have snapshot.data. So that gives us literally the data that we wanted. Because earlier, if you see in the main.dart file, when we wanted to get the user object, we had snapshot.data and we've done a similar thing over here. snapshot.data. Now on this data that we got, I want to get all of the documents that are present over here. Now I just don't want to get the document ID, right? I want to get a document such that I can call a method and get its data. And that's why this docs is of the type of query document snapshot. And for the item count, this docs.length works because we want to fetch all of these data, right? So whatever the length of this list is, the list of these documents, that will be put in as the item count. Then in the item builder, we return a row, expanded child color, and here as the data, we have snapshot.data just like earlier, then docs, which is a list just like this. And then we grab the document at a particular index. Since we are in a list view builder, we're basically looping through this entire list and trying to return a widget. And that's why we have .docs at index. So in the first try, we have index 0, so it gives us that. Let's say we had another document, we would have index 2, and that would be displayed over here. Good for us. And we do the same thing for all of them. We also call the .data method, and that's because we want to get this particular data of a document. And this data gives a map of string, dynamic. It's dynamic because here it is a string in color, but in date it is a timestamp. In description it is a string. That's why it is a string, dynamic, and we get a key value format. So we access the date property on it, description on it, title, and color. If you understand these basics, it's very easy to move forward. Now let's say I didn't want to get all the tasks. I wanted to get only one task. And I told you we could do that earlier if we just knew what the ID is going to be. So if I pass in .doc and pass in the ID, let me just pass in the ID. So let me copy this ID, paste it over here, and then we can call the get method on it. However, you'll notice that we have errors down there. And that's because the snapshot is no longer query document snapshot. It is a document snapshot. So instead of getting these queries that are present over here, we directly get the document snapshot, the data that's present over here. And now we won't be using list view builder or anything because we only want one task's data, right? That's what I mentioned over here. Get me the data of one particular task. So now I can simply remove all of these things. No list view builder is required. And now we can just do snapshot.data. And this data is going to give me map of string, dynamic. So I can just do snapshot.data color. And the same thing goes for here. Snapshot.data title, snapshot.data description, and snapshot.data date. Now I can save this. And as you notice, we see the same card again. There's no visible difference. And that's because we have only one task in our application. Let's try to add another one. I'm going to go ahead and add task 2. The description is going to be hello. Let's pass in this blue color and then click on submit. If I go back to the Firebase console, I see that the new data was added. And if I go to the add new task, I don't see it. Now here's one interesting fact about this get method. It is a future, right? So it's not giving us real-time data from Firebase Firestore. It's only giving us data from the last time it was rebuilt. And the last time it was rebuilt is when I restarted the application. So if I restart the application, then I'll get the latest batch of data, and still we only get one card. So that means we were successful in getting just one document. If we wanted to go ahead and prove ourselves more, we can do snapshot.data like that. And you'll notice we get this particular thing. Also, one interesting thing you'll notice is that here we did snapshot.data color and it gave us the right values. But when we did snapshot.data print over here, we got instance of JSON document snapshot. And that's because on instance of this JSON document snapshot, we can call this operator and get the particular JSON. But when we're trying to print it, it won't work. That's why we need to call this .data, which will give us a map of string, dynamic. And yeah, as we see, there's only one data that's being fetched. Now I would like to go back to my previous version of list view builder so that I can go ahead and show you how we can fetch data real time. because fetching data real time is one of the biggest features of Firebase. And as you can notice, we have the second task over here. Let me go ahead and add a task 3. The description is going to be there. Then let's just select a color, submit, go back, and the task is in there. Now let me restart the application and you'll see we have a task 3. That's what I'm talking about. I don't want this data fetching to be whenever I restart the app. I want it to be real time, and Firebase can help us with that. So instead of doing Firebase firestore.instant.collection tasks.get, we can do .snapshots. And this will give us a stream of the same thing. Earlier, it was a future of query document snapshot. Now it's a stream of query document snapshot. So instead of using future builder, we'll use stream builder. Then there's going to be stream. And then we have the same logic. If snapshot.connection state is equal to connection state.waiting, if no data, otherwise we return the expanded list view builder, and there we go. So with just this much change, we have converted our application from future to stream. That means from non-real time to real time. Let me demonstrate. Let's add a task 4. The description is going to be hey there. Then we are going to have a pink color. Let's say with this white. Click on submit, go back, and we have a task 4 automatically added over here. So that's how easy it is to use the Cloud Firestore SDK to do what you want. We basically had to make no change over here, and that's because this snapshot is of the type of stream query snapshot, and when we did get, it was future query snapshot. So nothing else changed in our code. The SDK is so similar that it helps us a lot. So now that we have this in place, let's go about filtering this data. The first thing that I want to do is, as you noticed over here, the tasks present are all the tasks that are stored over here. And we would want that in a social media application, but not in a task management app. In a task management app, I want all the tasks that are created by a particular user. Now, as of now, all of the documents that are present over here are created by our user. But let's say there is another application running. Let's say we were running it on our Android application, and that is one another user. It is not this ranawat@gmail.com user. That user would also publish data in this tasks collection, so it would be added over here, and that means we are fetching that user's task as well. And we don't want to do that. So how can I restrict that this task can only be fetched by our particular user? The easy way to go about this is let our each document know who the creator of this document was. For example, this document's creator was our particular user, so I can store their user ID, right? The authentication tab, if you see, gives us user ID. I can use that user ID to add a field over here saying, hey, this user created you, you belong to this user. And then when we are fetching the data, we can add some sort of filtering condition that, hey, if the creator of this document is the user ID that matches with our current user's ID, then we want to get the task. Let me explain it. If I go to the add new task, and whenever we add a new task, now I'm going to add a new field to this. You can call it creator, you can call it UID, whatever you want. This is going to contain the current user UID. So we can simply do Firebase auth dot instance dot current user dot UID. And notice over here, I've used an exclamation mark instead of using a question mark, even though it allows us. That's because this current user cannot be null in this add new task page, because this page is only visible after the user is logged in. So the current user does exist. Now I can click on save, and whenever I add a new task, a new document is fetched. So let me say task 9. Then I'll select an accent color this time, click on submit, go back. We have a task 9 displaying over here. That's nice. And if I go to this document, we see the creator with this ID. It will match with the ID that's present in the authentication tab. No need to worry about that. Now, when I'm trying to fetch the data on my home page, Firebase firestore.instant.collection tasks, and we'll specify a condition over here that says that, hey, if the ID present in the database matches our current user's ID, then we want to get the data. Otherwise, we don't want to get this data. So we'll just do dot where. And then it requires us to pass in the field name. The field that we want to check is the creator field, right? This is the field that we care about. So if the creator field is equal to, and there are multiple options that you can use over here. For example, is equal to, is not equal to, is less than or equal to, and so on. I want to do is equal to because I want to directly compare the two strings together. And here I can pass in Firebase auth dot instance dot current user dot UID again. If this creator is equal to this current user's ID, then we get all the snapshots. And with this, we only get one particular card. You might wonder, where did the rest of them go? It was the same user that added this, right? Even then it's gone. And that's because it's relying on the fact that the creator ID is present everywhere. And if the creator ID matches, we display the post. And the creator ID does not match for the rest of the cards. So let's go ahead and take this UID and try to add a new field to this card. Let's say I pass in creator with this ID, click on add, and you'll notice a new card displays over here because the creator ID matches now. So yes, the cards that do not have the creator ID will not be displayed. Now this might seem like a waste of time up front, but let's say we have another user. Our Android user joins the conversation. It comes in, goes ahead and uploads a new task. The new task is displayed over here. The creator ID is different. So that particular task will not be fetched for this particular user. And that's how easy it is to fetch one user's data. One thing to remember here is that this where is only present on a collection. And that makes sense, right? If you think about it, because whenever you have a collection task, then you want to filter based on everything because you're getting potentially a list of tasks or a list of documents. If you do .doc, you won't have the ability to call .where because you're already at a particular document. Why are you trying to check if a particular field in that document is equal to something? You can just fetch the data and check it for yourself. But yes, the snapshots thing is still present on a particular document because if the field value changes, the stream builder needs to change. So it makes sense over there. So with this, we have completed the retrieval and filtering of our tasks. Now I would recommend you to start the Android application and try to see how it all works out and why the logic is present as it is to make more sense of it. When you see another device trying to upload the data in the same database and then trying to retrieve only a particular creator's ID, you'll understand it better. Now the next thing I want to do is as soon as the user just swipes right, I want to delete this task. How can I do that? For that, we'll have to wrap our row with a widget called dismissible. This dismissible requires the key argument to be present, so I'm going to pass in the index as the key, and this key needs to be of the type of key, so I can just pass in a value key passing in my index. Now I can specify my main function, which is on dismissed. So whenever this swipe right gesture is detected, I want to dismiss it. If this direction is equal to dismiss direction dot end to start, then I want to delete this data from the database. And to do that, I can simply do Firebase firestore dot instance dot collection tasks. So with this, I've gone to the tasks collection and now I want to go to a particular document and delete its data. I will have to go to the doc and try to delete that because on a doc, there's a delete option available. You don't have a delete option on a collection because you can't delete a collection. Just like you can't delete a drawer completely. You can remove all of the elements inside of a drawer, but that drawer is still going to remain. The same goes with collection. So here I want to specify a document and then I can delete the document. Now how can I get this document's ID? To do that, we have snapshot.data, right? So I can simply do snapshot.data.docs at a particular index dot, and you'll notice that we have an ID displaying over here. So this was the same part as this thing, but then we called .data to get the key value pair that is present over here. But now what we're doing is called the ID part on it. And that's why this docs was a list of query document snapshot. It allows us to fetch the ID of a particular thing. Now I can simply save this. And now if I swipe right and go to my Firestore database, that document is now gone. And if I go back to my task, there's only one task present now. Also, one thing you'll notice over here is that I've not done await Firebase Firestore.instance.delete. And that's because this is of the type of future void, even if you don't do it, but I would recommend you to just do it as a safety measure. So now we've seen how we can create document, how we can read from documents, how we can delete documents. The one thing that's left is how we can update a particular document. And I'm not going to spend too much time on it trying to make this as perfect as possible in terms of UI. So what I'm going to do is just show you how you can update a document. Just like we had a delete function over here, you can have a .update function on this. Then you can pass the data that you want to update. And you can see that it updates data on the document and the data will be merged with any existing document data. So that means, let's say I have a new field that's added over here. Let's say new field. And then we say, hey, this is just an example. So I just try to swipe right over here and we get this error because it is totally dismissed. That's how dismissible works. If you restart the application, you'll see that the task is back. But if you go to this particular thing, you notice that we had somewhat of an orange color over here that says something was updated, and it says that new field hey was added. Let's say I add new field hey 1, but I also update an already existing field. So let's say I update color to be FFFFFF, and this color should also be a string. Now I'll try to swipe this off. Again, we get the same error because that's how dismissible works. Nothing with Firebase error. So I'll just restart the application, and again you notice that we have new field hey1. The new field hey1 was now updated. Instead of creating a new field, it updates the already existing one. And even the color is now FFFFF. And if I go back over here, the color is white because FFF stands for white. So that's how easy it is to update a particular document. Again, you can't do this on a collection because you can't update a collection. If the collection is present, it's going to stay as it is unless it is deleted manually from the Firebase console. And if you want to delete a collection or make it seem as if the collection is deleted, you can delete all of the documents that are present inside a collection and then it will be gone. For example, if I go ahead and delete each of these documents and then refresh the page, this tasks collection will be gone. So now that we have understood all of this, I'm going to remove this entire dismissible thing and go back to the add new task page. In the add new task page, we add a function of upload task to DB. And I told you that I'll show you how we can create our own ID and add it as a document and how that would affect rest of the code. Let me show it to you. So to create an ID, I would recommend you to just add a new package called UUID. This will allow you to create a universal unique identifier, and that just eases a process by a lot because you have a guarantee that most of the IDs are not going to be the same. Especially for the number of users my application is going to have, let's say 100, it's going to be different for each of them. So let's say we have constant ID equal to UUID dot v4. You can also have v6 if you want, either one of them is fine. And it says it can't be invoked in a constant. So let me just put a final, and this UUID class is a constant. Now I can take this ID and add it as a document over here, .doc ID. Again, having your ID is very crucial because it will determine a lot about your data. If it's going to be merged or is there going to be new data, it's very important. So now that we have .doc ID, you notice that this add gives us an error, and it says that this add function is not defined for document reference. And that's because when you do doc, you get document reference. When you're on collection, you have collection reference. On collection reference, this .add is present. Because think about it, in your drawer, you want to add a new data, but in your particular document, you want to set a particular data, right? So you need to call .doc.set. And that will make sure that a particular document with a particular ID is set. Also, we don't have data.id anymore. That's because when you do set, it returns future void. So you don't have any data, because why would it give you a document reference? You already have the document reference. In collection, it made sense to give you a document reference because you didn't know what the document ID is. But in .doc, you already have the document reference. This is it. So we don't even have data.id because our ID is created by us. We are managing it. And now we have done this. And now if I try to add a new data, let's say hello, click on submit, go back. We have hello displaying over here. Everything works fine if the user sees it, but on our backend, you see that this ID is quite different from these auto-generated IDs because that's the one UUID created. Now, I would also recommend that if you're creating your own ID and setting it over here, you also have an ID field over here. It just makes things a lot more easier if you have multiple operations to do. So that's just a tip I would have. Also, this document can be any form of string, all right? It can be your task name if you want. And that would be a good option if you want to make sure that no document over here can have the same title. But it also puts a restriction on your document that this document cannot change its title because an ID cannot change throughout its lifetime. If this document is present with this particular ID, this ID cannot be changed. If you want to change the ID, you will have to take this key value pair, then create a new document with a new ID and then paste all of that data in. So I generally prefer letting Firebase do it or just using UUID. I don't put it on a title or anything. It would also be a good option in some cases to let the user's ID be some sort of document, but use that wisely because if you use the user's ID in this scenario, it's going to be problematic. Because let's say we have tasks, user ID as a document, and then we upload some data. Now let's say we have second task uploaded. So we have task, then we pass in the user ID, and then we update that data, or more like override that data. That means one user cannot have more than one task. So that's one thing you'll have to keep in mind and figure out which ID to use when. It will come with practice and you just have to put a bit of logic in. So with this, we are done with the Firestore part. Now the next thing I want to do is how can I store images using Firebase? Let's say I was actually creating a social media application and I want to allow the support for image sharing. How can I make sure that Firebase also processes that? So let's say in our task page, we had an image plugin that's allowed over here. Now you could select an image over here, then pass in the title, description, all those sorts of things, and then click on submit. Then you also have an image displaying over here somewhere. How can you do that? You might think that we can still use Firestore database, right? It's storing all the text related content. It's also storing dates. It's also storing Boolean values. It can also store arrays, and images are basically arrays or lists. So we can use Firestore database, and you are right to put in that logic. But there's one problem. Firestore database is not good with image sharing. That's because in Firestore, the limit of size of each document, so this document, the document size is just 1 megabyte. And as you know, images are more than 1 megabyte most of the times, especially with increasing camera qualities. So you can't store images. And in your application, let's say you also wanted to allow the sharing of videos or any sorts of file like PDF documents. You can't store all of them in Firestore. That's one limitation of Firestore, or more like Firestore wasn't designed for this kind of thing. And for this particular reason, we have something known as storage over here, Firebase storage. So we can click over here and get started. Then again, it asks us to pass in the rules for cloud storage. You can start in production mode or test mode. I'm going to start in test mode. Make sure your rules are like this. You allow read and write. In production mode, read and write is disabled, meaning you can't ever read or write to this. So you can click on next after that, then click on done. And then it will create a storage bucket for you. And this is where you can upload your data. You can upload your images, you can upload your videos, you can upload your file documents. It allows for all types of things, any sort of files. It gave me an error over here that it failed to initialize the storage bucket, but when I refreshed, I came back to this storage page. So it's initialized properly. So as you can see, I can upload my file over here. I can create a folder if I want to, and do all sorts of things related to files. Now just uploading a file here isn't enough because it's not connected to our Firestore database. Because let's say you upload a image over here, you click on submit, you store it in the storage. Now what? When you're retrieving, you're still retrieving from the Firestore database, and Firestore database and the Firebase storage are not connected by any means. They're both independent services. So what I want to do is create a dependency between both of them. Firestore should depend on storage. Meaning what I'm going to do is, let's say this is my Firebase storage. This is my Firebase Firestore. What I'm going to do is as soon as an image is taken over here, I'm going to upload it to Firebase storage. After I've uploaded it to Firebase storage, it's going to give me the image URL that I can use. So after it gives me that URL, I can take that URL along with these fields that are present over here and then upload both of them to the Firestore database. So with this, my image is stored properly and in the proper size. The retrieval and all of those processes are very optimized for Firebase storage, so we don't have to worry about that. Then after it gives me the URL, I can upload it in a particular document along with the other fields like title, description, color, and therefore we are ready to upload and display the images as well. If it seems tricky right now, don't worry, I'll come back to this diagram and explain again when all of the code is written and we have a more concrete code example of this. So to connect our app to Firebase storage, what we are going to do is install the Firebase storage plugin. Just like we had for Cloud Firestore, Firebase Auth, we also have Firebase storage. So let me copy this, then add a dependency of Firebase storage. I'm going to stop running my app and then restart it. I'll see you after the app starts rerunning again, and then we can get into the code of how this works. I'm also going to write out the logic for the image picking from gallery part so that we don't spend much time on that. We can focus on the main Firebase part of the tutorial. So the app is now loaded, and if I go and click on the plus button, then select an image over here, I'm able to select an image and I'm also able to change the image if I want. Now the next thing I want to do is whenever the user clicks on submit, I want to upload this image to Firebase storage and get the URL. After we get the URL, I can explain further. So the first step is just to upload to Firebase storage. Let's do it. So I'm going to go to the add new task page, and here we have upload task to DB function. Now what this is going to do is upload our image to Firebase storage, and we also have the call to Firebase Firestore to set the data over there, but we are going to ignore it as of now, just focus on Firebase storage. We can use Firebase storage the same way we used Firebase Auth and Firebase Firestore. We are going to import Firebase storage plugin and call the dot instance on it. Now here we are going to call ref. Ref is going to return a new reference to us. What is a reference? A reference is the starting point for storage operations. So as it says over here, if the path that you pass in over here is empty, the reference will point to the root of the storage bucket. If you know what the ref is going to be from the beginning, you can simply pass it in over here as a string. Let's say I want to store my file in images folder. So I can pass in images over here and then continue forward. So I'll pass in images over here and then click on dot, and it gives us a bunch of other options. As you can see, we also have a child option. This child is creating a new reference relative to an existing reference. So this means whatever reference you passed over here, it's going to be relative to that. So that means if I pass in the images, and let's say I pass in ABC over here, then my reference in Firebase storage is going to be images/ABC. You can think of it in terms of folder structure. We have images, which is going to be a folder, and in there we've created ABC. So that's what child allows us to do. Let's say I had passed in here another child, which is XYZ. So this is going to be images/XYZ/ABC. So child is basically just returning a reference to us, but in a relative format. It builds upon the existing reference that already exists. So ABC builds up on images/XYZ. So you might wonder, why is there a ref and even a child? And the reason is that if you know the reference from the beginning where you want to store your file, you can just use ref. Or whenever you want to start fresh from scratch, you can use ref. But if you want to start from an already existing path, then you would use child. The way I use ref generally is that I just create a reference, so let's say images reference over here. And now what I can do is images ref dot child and create one path based on this, let's say ABC. Then if I want to create another path, I can again do images ref dot child XYZ. So with this, I've created two references and they both are different, but this is much cleaner code, right? I don't have to write firebase storage.instance.ref followed by .childabc and again write firebase storage.instance.ref .child xyz. So that's how ref and child can help us. But anyways, in our case, we can just do .ref .child just so that there's better readability. If you want, you can also do images / and then whatever I'm going to do. But yeah, so now we have child. Now what path do I want to pass in this child? Remember, if I put something over here and then proceed to just upload the data to Firebase storage, the path that's present over here will become the file name. For example, if I have images / whatever name I have, let's say name. So my file name is going to be name. That's it. It's going to be present in the images folder, but the name of the file stored in the Firebase storage is going to be name. But if you want to convert this name to a folder, you can just create another child and then pass in the file name. So in our case, maybe we just want the ID to be the file name. I can also take this ID and put it at the top. And this way, the entire path is going to be images / name / whatever ID is automatically generated. So this and this ID that we have is going to be the file name. Images and name are going to be the folder names. All right. I hope that's clear, because if you have the same file name for everything, it is going to create problems because you're going to overwrite certain files and you don't want to do that. So yeah, I'm going to remove the child name from here. I just want images followed by the ID, and the ID is going to be the name of my file because this image is only present for a particular task. So after we've created the reference, what we need to do is upload this data to Firebase storage. And to do that, we can simply do images ref dot put, and you'll see we have 4 options over here: put blob, put data, put file, and put string. If you use put blob, it will accept the type of dynamic. Basically, it will allow you to upload a blob, and it is only supported on web platforms. And if you're wondering what blob is binary large object. It is a data type that represents images, audio, or any other type of binary data. Other than that, we can also use put data, and this allows us to pass in uint8 list. Again, this can be used on web as well as mobile apps. So if you convert your file into a uint8 list by just doing file.read as bytes like this. So let's say we have file.read as bytes sync. You'll notice it will return uint8 list to us, and then we can use it on mobile. However, Dart.io library is not supported for web related tasks, and that's why you need to use uint8 list over there by default, and that's where it can help you. But in our case, we just want to do put file because we already have a file of the type of file. So we can just pass that in, and there we go. Here we are assuming that the file is never going to be null, just like we are assuming that title controller.text.trim is never going to be empty. But if you want, you can add your if conditions and validations over here, but I'm not looking into that. Now put file is going to give us an upload task, which I can store as this. Upload task is equal to this. Now you might ask, what is upload task? Upload task basically represents the entire upload process. It gives you control over starting, pausing, resuming, or canceling the task that's happening, basically canceling this put file operation. So if I do upload task dot, you'll notice I have option to cancel, ignore, pause, resume. But what we are interested in doing is await this. If we await it, we get task snapshot. What is task snapshot? Task snapshot provides progress information such as the number of bytes that have been uploaded so far, the total number of bytes, and the current state of task. Is it running? Is it paused? It is completed? All that sorts of things. It also allows you to capture the error and give the error details. Now you might ask, what is the difference between task snapshot and upload task? And to understand this, you might like an analogy. Think of upload task like a delivery driver taking a package to its destination. Our package is the file and the destination is this reference. Alright? So upload task is responsible for the entire delivery process, including starting, pausing, or canceling the trip. Now, a task snapshot is like receiving an update on the delivery's progress, telling you where the driver is. So it tells you where the upload task is, how much of the route has been completed, and if there are any other issues. So the driver, that is the upload task, will control the journey, while the snapshot, the task snapshot, will give us the real-time updates. So having understood that, what we can do is use task snapshot dot, and you see we get bytes transferred. That means how many bytes have already been transferred, dot ref dot state. But what we are interested in is ref. And after we do ref, we get the ability to get the download URL at that ref. Basically what we are doing is after we've uploaded, we go to the reference, so this reference, and get the download URL of the file that's present at the reference. And that download URL is going to be the image URL. So we can just do final download or image URL, which is equal to this. And then I can go ahead and print this image URL just to verify everything went well. Also make sure you await this because get download URL is of the type future string. And note, because of these two lines working together simultaneously, we will wait for the upload to complete and then only we get the download URL. So that means we get the right URL. Now I would like to test this out. So I'm just going to go over here and let's say I pass in some title, the description, some color, and then I click on submit. If I come over here, open my terminal, I see Firebase storage unknown, the operation could not be completed, status error 400. Whenever we get status error 400 in HTTP, that means there's a bad request. And if there's a bad request, the first thing I would recommend you to do is go to your storage rules and notice that a rule says allow read write if false. So that means no read write is allowed and we don't want to allow that. So I'll remove this if false, only keep allow read write and then publish. This is not secure. So if you're deploying your app online, make sure you change your security settings or the rules. Now that we have fixed it, we can go ahead and click on submit again. And here you see after a bit, we get the Firebase storage URL. And if I click on it, open it, I see the image over here. And if I refresh my Firebase storage, I see images folder over here followed by the name of the file. And the name of the file is the ID of the task that was added to Firestore database. So now that we have Firebase storage done, there's still no way for us to know that this particular task that was added, yes, has an image. If we try to print it, let's go to the home page. And when I'm trying to print it, I'm just going to go ahead and print this particular line where we have snapshot.data docs@index.data. So it will give me a JSON, which I can just do. And as you can see, we have these information, but we have no information about the image URL. So what I want to do is whenever I add a new task, I get the image URL and I store this image URL in Firebase Firestore. So this way, whenever we are retrieving the data from the Firestore database, we also get the image URL. So after doing that, I would like to upload a new task and let me select a nice image. Let me select this one. Then the title is going to be new image. The description is going to be new image. Let's select the wheel this time and this looks good. Click on submit. As you can see, we have a new image in our Firebase storage. So I can go ahead to my home page and you see we have new image showing up. And also when I go to my tasks, you'll notice that we have an image URL for one of the tasks. That means the image URL was successfully connected. And if I want to display it, I can do it very, very easily. All I need to do is pass an image URL over here. As you can see, rest of the images have null in it because no field like image URL exists in those documents. But in one, we have this Firebase storage URL. So I can take this and put it in my network image or anything I want. So for example, I can simply go ahead and add it as an image over here. Then I'm going to pass in the decoration image. And this image will require me to pass in the network image because essentially this is a URL coming from network. And after doing that much, you notice that we get an error over here. Type null is not a subtype of type string. And that's because image URL doesn't exist for everybody. So here I'm going to put another condition that, hey, if the image URL does not exist, that means if it is equal to null, then it is going to remain null. Otherwise, we can use the decoration image. And as you can see, everything shows up. And if you zoom in a little bit over here, you'll notice that this is our image that we uploaded. I'd like to increase the height and width of this just so that you can see it better. Let's make it, let's say 50, save it, and there we go. It's visible over here. So just for demonstration, this is how we can upload images. But if you wanted, this file could be video. So you could use image picker to pick videos and then call imageref.putFile, and your file could have been a video. If you wanted, it could have been a PDF file and you could use the same method, but this method only works for Android and iOS. It does not work for web. For web, you would have to convert it to uint8 list and then upload it because Dart.io is not supported on web. So remember that. So to revisit this diagram again, we have Firebase storage over here. We have Firestore database over here. So we have an image over here. We took the image or any other sort of file and uploaded it to Firebase storage. Here we specified the folder structure, the file name, everything, and stored it over here. So from that particular reference, we got the URL and we took that URL and added it to our doc. So this is our key value pair where we have added an additional image URL. Then we took all of those fields that are present over here and uploaded it to Firestore database. So this way we were able to make connection with Firebase storage. And whenever that link is visited on, it will take you to the particular Firebase storage. So with this, we have made a connection between Firestore database and Firebase storage. And with this, we've covered Firebase authentication, Firestore database, storage, and I also told you the reason for not using real-time database. So this is it for the video. Thanks for watching, and I'll see you in the next one.